Okay, so if you're writing in Java, you know you're dealing with data, like all the time. But what's the best way to actually store it and manage it? Well, today, we're going to crack open one of the most essential parts of any Java developer's toolkit, the Java Collection Framework. So here's the game plan for this explainer. First up, we're going to talk about the problem. Why isn't the good old array always the right tool for the job? Then we'll get into the good stuff, unboxing the collection framework and really digging into the big three: lists, sets, and maps. And to wrap it all up, we'll put together a super simple guide so you'll know exactly which tool to grab when you need it. Sound good?
All right, first things first. Before we jump into all the cool new tools, we've got to understand why we even need them. Let's talk about the problem we're trying to solve. And for a long time in programming, when you needed to group a bunch of stuff together, your go-to was the simple, trusty array.
Okay, so think of a classic array like a metal chain. When you make it, you decide how many links it has, and that's it. It's fixed. You can't just add another link later. Plus, if you want to find a specific link or sort them, you have to build all that logic yourself. Now collections, they're totally different. Think of them like a flexible, magical bag. It just grows whenever you toss something new in. And the best part? It comes packed with all these handy tools to add, remove, search, and sort your items. It saves you so much time and headache.
And that right there brings us to the elegant solution for all those array headaches. So let's officially introduce you to your brand new shiny programming toolkit.
So the Java Collection Framework, or JCF for short, it isn't just one single thing. No, it's a whole system, a complete architecture of ready-to-use classes and interfaces, and its whole reason for existing is to make your life easier by giving you powerful, super efficient ways to handle groups of objects. You can just think of it as a professional-grade set of containers for all your data. All right, take a look at this. This is kind of like the master blueprint for the whole framework. You see, everything starts from that top-level collection interface. And from there, it branches out into more specialized blueprints, like list, set, and queue. Now, queue is super important, for handling data in a first-in, first-out kind of way. But for today, we're going to zero in on the two you'll use most often, list and set. Plus, we'll look at another really powerful tool that's kind of its own thing, the map.
Okay, let's grab the first tool from our toolkit and see how this all works in practice. We're starting with the one you're probably going to use 90% of the time. It's the workhorse of the framework, the list.
Okay, the two magic words you need to remember for a list are ordered and allows duplicates. See, a list keeps everything in the exact order you put it in, just like a music playlist, right? The first song you add is track 1, the second is track 2, and so on. And hey, if you love a song and want to add it to your playlist 5 times in a row, a list is totally cool at that. No problem at all.
So when you actually go to use a list in your code, the most common version you'll reach for is the ArrayList. And this is a really important point, the difference between an interface and an implementation. Think of the list interface as the blueprint for a car. It says a car must be able to accelerate, brake, and turn. An ArrayList is the actual physical car you can drive. So an ArrayList gives you the best part of a regular array, that super fast access to items, but it gets rid of the biggest headache, that fixed unchangeable size.
So, when should you grab an array list? Well, it absolutely shines when you're mostly just reading data from your list. Because under the hood, it's still an array, grabbing an element by its index is lightning fast. But here's the catch. If you're constantly adding and removing things from the middle of a big list, it can get slow. Why? Because it has to shift every single element after that spot. So, yeah, it's the perfect go-to choice for a dynamic, ordered list, as long as you're not doing a ton of insertions and deletions in the middle.
And here's what it looks like in actual code. See, the syntax is really straightforward. You just declare your array list, you tell it what kind of stuff you're going to put in it, in this case some strings, and that's it. You're ready to start adding items to your brand new flexible list.
Okay, so ArrayList is awesome, but this brings up a really important question. It's totally fine with duplicates, right? But what if that's a huge problem? Imagine you're keeping track of user IDs or email signups. You absolutely cannot have the same one in there twice. So what do you do then?
For a job like that, you need a specialist. You can't just use your general purpose hammer. So let's pull out the next tool from our kit, the set. And a set has one mission, and one mission only, to guarantee that everything inside it is unique.
So let's see this in action. First, you've got a regular list. You add A, then B, then you try to add A again, and then you add C. The list just says, sure, no problem, and you end up with 2 A's in there. Okay, now watch this. Let's try to do the exact same thing, but with a set. You add A, you add B, and then when you try to add that second A, the set just says, nope,
already got one of those and quietly ignores it. The result? A collection that only has unique items. It's all automatic. It's just so useful.
And the official definition really nails it. A set is a collection that absolutely guarantees no two elements are the same, period. If you remember any of your high school math, it's based on that same idea of a mathematical set, where every member has to be distinct. But just like with list, set is just the blueprint. So which actual type of set should you use? This little table here is basically your cheat sheet. So if all you care about is uniqueness and speed, and you don't care what order the items are in, hash set is your guy. It's the fastest. Now what if you need them to be unique, but you also want to keep them in the same order you added them? For that, you'll want a linked hash set. And finally, if you need your unique items to always be sorted, like alphabetically or numerically, tree set handles all of that for you automatically. Pretty cool, right?
Okay, so we've got tools for storing a bunch of individual items, whether we need them ordered or totally unique. But what happens when data doesn't come alone? When it comes in pairs? You know, like connecting a name to a phone number or a username to a user profile. How do you handle that?
For that kind of job, we need a totally different kind of container. So let's dig into our third and final major tool, the map, which is all about linking pieces of data together.
The absolute core idea of a map is the key-value pair. You use one piece of data, which we call the key, to look up another piece of data, the value. So for example, the key might be the name Amit, and the value it's linked to is the age 35. The best analogy is a dictionary. The key is the word you look up, and the value is its definition.
And just like our other tools, map is an interface, a blueprint, with its own family of powerful implementations. Now, here's a key detail you might notice on this diagram. See how map is off to the side? It doesn't actually come from that main collection interface we saw earlier. And that's on purpose. The collection world is all about handling single individual items. The map world is built from the ground up to handle these key value pairs.
So, which map do you choose? Well, the decision process is going to feel very familiar because it's almost identical to choosing a set. If you need the absolute fastest lookup speed and you couldn't care less about the order, hash map is the king. If you need to preserve the order that you put the pairs in, linked hash map is what you want. And, you guessed it, if you need all your pairs to be automatically sorted by their keys, tree map is the one for the job.
All right, we've covered a lot of ground. We've unboxed three incredibly powerful tools: the list, the set, and the map. So now, let's put it all together. We'll create one final, super clear summary so you always know which tool to reach for. This right here, this is the ultimate takeaway. If you remember one thing, remember this. You need a list when order matters, and you're okay with duplicates. You need a set when uniqueness is non-negotiable. And you need a map whenever you're working with key value pairs. At the end of the day, it really is that simple.
So, by getting a handle on these three fundamental structures, you've officially leveled up. You've moved way beyond the limits of simple arrays. You now have a versatile, powerful, and efficient toolkit for handling pretty much any data management task Java can throw at you. So the only question left is, what problem are you going to go solve first?